now it looks like you're given grams. So you got 285. This is number 8, by the way. 285 grams of iron. 3. Let me make sure I did the last thing right. What was it? Oh. Duh. Wait a second. 1 second. Alright, so since you're giving grams, you in this case have to use the molar mass. So you're going to use 285 grams. Oh, wait, sorry, I didn't write the rest of it. Iron 3 phosphate. Oops. Alright. So, let me explain before I even do this. Okay, so you have iron 3 phosphate. In this case, you are using a transition metal. Now remember, when you are naming elements or compounds, when you have a transition metal, usually transition metals, well, not usually, well, most of them, I mean, except besides zinc and a few others, most of them have 2 charges, which iron, I believe, has a +1, and I believe it has a +2, if I'm not mistaken. Yes. No, sorry. +2 and +3. Sorry. It has a +2 and a +3. It has 2 charges. So you can't just write iron phosphate, because you won't know which charge to write, technically, if you knew the charges. Now, if you didn't know the charges, that would be a problem. Alright. So, this one is nice because it gives you the charge. Phosphate, you have to know that charge. You have to know this charge. So, let's write that. Fe3+. Alright. Let's write phosphate, which is PO4. And what's the charge? 3-. It's the one with the 3-. So, we obviously can tell that those cancel out, which will just give you FePO4. There's no need for parentheses because you don't have a subscript. The only subscript is 4, but that only goes to the O. But we already know that. Technically, you know that. Because if now the 4 was going to the P and the O, you would have to put parentheses around both of them to show that it goes to both. But in this case, it only goes to the O because it was already there. It's already part of the compound. So that is your written that's your written thing. Alright, so let's erase that. Okay, so now we're going to start. We're going to obviously start with what is given. So what's given? We got to ask ourselves. Okay, we got 285 grams. So 285 grams of iron 3 phosphate, correct? Over 1, right? So now we've got to cancel out the grams. How do we cancel out the grams? Use molar mass. That's the only other logical thing. You got to be like, okay, you got to ask yourself, what can I cancel this out with? What can I cancel these moles out with? Usually when you cancel out moles, they're either given in the reaction, but it doesn't look like you learned how to do that. Looks like you're just learning how to do that, so that might be on next quarter's thing. And I could teach you that. That's easy too. But if you have, moles, you're just going to usually use 1 mole to cancel it out. But in this case, since you have grams, you can't use 1 gram because that's not right. You have to use the molar mass. So the molar mass of FePO4, you know how to do that. It's going to be, so obviously in this case we're going to put 1 mole on top because we are finding the molecules. So you can't just put molecules on top because that's not the thing. So then we got to cancel out, and then we got to put 1 mole here to cancel that mole out. And we put 6.023 times 10 to the 23rd. Put molecules. So basically when you're using molecules and atoms, it's the same conversion. This is 23, by the way. It's the same conversion. It's just you're using the word molecules and you're using the word atoms. So in this case, molecules is left on top, so we know that we did everything right. We canceled all this stuff out, so we know we're left with molecules. So you have 285 divided by 150.82 times 6.023 times e to the 23, which is going to give you 1.14 times 10 to the 24. And like I explained before, when you multiply exponents, you add them. So that's going to be your answer.